Also, without further ado, I would like to introduce to you Offer Mayer, CTO at Mitiga. Thank you for being here, talking to us about It's Getting Real and Hitting the Fan 2025. Think you see me? No, you don't. Thank you.
Thank you. Well, hello everybody. Thanks for being here on a Wednesday afternoon after lunch and dessert. I know it's not trivial, but I hope the session will keep you engaged. So we're here to talk about compromised identity attacks. So a little bit about myself. I've been in cybersecurity my entire life, pretty much 30 years now. Most of it in the prevention space, builder, breaker, defender, a lot of it in the AppSec space. In the last 5 years, I moved to the other side, to the detection, incident response. I always say I do cloud security a day and incident response nights and weekends, because that's just how things are. And in the last 5 years, I'm in the space of threat detection, investigation, and response for cloud and SaaS. And a lot of what I'll share with you today are things that come from my day-to-day work. So I hope it's going to be interesting. And we can start. So I think we all know, right? Breaches are inevitable. There's nothing new about it. We know that we can't secure everything. We know that we're going to get compromised. But the thing that is more interesting is where breaches come from. And in the last few years, we see a huge increase in identity breaches. And that is because identity is the new cloud perimeter. You've probably heard the term zero trust. It's a great term, right? It gives this notion that we don't trust anything. It really means that we stop trusting IP addresses and move to trust identity, right? And so the moment an identity gets compromised, everything gets compromised. And this is what this session will be about today. And we see that it is already the number one initial access vector. So if you go to any of those breach reports, I will quote some of IBM's today, but if you go to any of those breach reports, you see that a compromised identity is becoming the number one access vector for cloud. So what we're going to do today is we're going to learn about identity compromise breaches. I'll show you some stats. I'll walk you through 3 breaches that we investigated, that we were part of, and can share some information on, and how these looks in the real world. We'll talk a little bit about the challenges of detecting and responding to compromised identity breaches, because it's not trivial. And eventually give you some tips on what you can do today and in the coming months to be better ready to prevent, detect, and stop breaches. So I want to start with some statistics. And there are a lot of data breach reports. There's the Verizon, there's so on. I personally like the IBM one. It doesn't really matter. The numbers are overall pretty similar. So I took these from the cost of data breach report from IBM. I think they've been doing it for about 20 years now. And one of the things we see is that breach cost continues to rise, right? And that's not a surprise. It rises every year, so no big surprise here. It's rised a little bit more this year. It's almost at $5 million. Here in the US, it's almost double. So the average for North America is almost $10 million average cost of breach. So it's a lot of money for us to deal with. And one of the things that, if you haven't seen this before, are super, super important. One of the most critical parameters of how much a breach costs is how long does it take us to identify it, remediate, and respond to it, right? So in the IBM breach, they break it to under 200 days and over 200 days, because the average has been forever and around 270 days. So you can see that if it's over 200 days, the average breach cost was $5.5 million versus only $4 million if it's under 200. But what we also see that's really interesting is that breaches in the cloud are now the most impactful. And this is actually a change from recent years, because in the recent years, the most impactful cost-wise were breaches in hybrid environment, right? We've long seen that cloud is more impactful than on-prem, but hybrid was more impactful, generally because it's harder to respond to. But now the public cloud breaches are becoming the most impactful. Why? Because everything's moving to the cloud, and once you're in the cloud, lateral movement with identity is just so easy. And it's especially interesting when you see that it takes less time, a little bit, not a lot less, but less time to respond to public cloud breaches versus hybrid environments, right? 268 versus 283, but still the impact is higher. And so we'll talk about why is that throughout today. Another interesting stat that we see is that extortion is evolving. What does it mean? So when we think ransomware, we think the legacy ransomware, somebody got a malware on my computer, encrypted all my files, I have to pay to recover. But in the cloud, this type of ransomware is way less effective. And so we've moved to extortion. So we see a lot more extortion and destruction than actual encrypted type of ransomware. What is extortion? Is I'll publish your data on the dark web, or I'll sell it if you don't pay me, or I'll delete all your machines if you don't pay me, right? Destruction, exfiltration. One more thing that's interesting, again, this has been on the rise forever, but it's just an interesting stat to see. Did the data breach result in your organization increasing the cost of its product or services? Security breaches are impacting organizations to a level where they have to make up for it in increasing the cost of the goods they sell. And that is big. And it's now gone up to 63%. So let's talk about identity. So this is a really great graph. Again, IBM gets it out every year. This axis will tell you how likely a certain initial access vector is, and the other axis will tell you how much impact it is. And what you can see is that the two most likely and highest impact are phishing and stolen compromised identity. So both of them are around compromised identity. You also see that other impactful ones are business email compromise and malicious insider. What all of them have in common is that they are compromised identities. Again, malicious insider is not a compromised identity, it's a bad identity, but still. Whereas things like cloud misconfiguration that, 2-3 years ago, everybody was talking about cloud misconfigurations, way lower probability, way lower impact, and then 0 days and vulnerabilities are going year by year lower. Identity is your biggest concern, and if you're not there yet, you should start thinking about it. And finally, you see also that this translates into the challenge in detecting and responding. So identifying stolen or compromised credentials takes the longest, again, on average, than any other type of breach. Why? Because it's just a legitimate user doing things in your systems. There's no exploits, there's no vulnerabilities, there's no scanning, there's just a user logging in. And what we're seeing is adversaries no longer break in, they log in. And it's growing exponentially. So let's talk a little bit about examples. So I want to start with the Snowflake breach. I'm sure most of you have heard about this last year. Considered maybe one of the biggest breaches in history, although I think MGM is giving it a good fight. And what's really interesting is that Snowflake wasn't breached, right? So there was a lot of noise in the media. Snowflake wasn't breached. A lot of Snowflake customers were breached. And we were one of the first to investigate this. One of our customers were impacted. What you can see here is just what was published. And it's just a small percent, right? So 165 organizations were breached in the Snowflake breach. Some of them hugely impactful. Probably the noisiest one was Ticketmaster. So Ticketmaster had total disruption, couldn't sell tickets, stopped working. AT&T had tons of mess. Some people claim they paid the ransom, not sure. Santander, big South American bank. So you can see here, some of these that didn't pay the ransom ended up having their records being sold. So you can see the number, right? Lending users were sold for $2 million, Advanced Auto Part for $1.5 million. So the hackers walked away with quite a lot of money. By the way, they were arrested later. At least some of the group was arrested later. But this was a really, really big breach. And there were no vulnerabilities used, only signing in. So let's talk a little bit about this breach. What happened there? At the core, the attackers connected to a Snowflake instance of one of these 165 compromised companies and exfiltrated all the data from the Snowflake. So Snowflake, big data, biggest data repository for a lot of these customers. They exfiltrated all the data using a custom tool that they wrote that went, mapped all the tables, did a query on them, and stored it outside of Snowflake. It was all using standard Snowflake capabilities. So there's not a single signature pattern that could have recognized anything here. So how did they do that? So the initial access was by obtaining credentials from infostealers. So infostealers, malware that are going to steal passwords, cookies, credentials from computers. People work from home. Some organizations don't enforce using only your work computer. They log in from home to company assets from their home computer. They don't take good care of their security, whatever. The kids go on weird sites. And one of the things that helped this campaign be so successful is that Snowflake not only didn't make it easy to use MFA, it made it hard to use MFA. So a lot of Snowflake customers didn't have MFA. And so they just simply gathered from infostealers credentials for Snowflake. They had some enumeration tool that allowed them to identify the instance, because when you log into Snowflake, you need to know which instance you go to. And then they simply logged in. And then they used it for extortion. Some people paid it, supposedly. Exposing it or selling it on the dark web. And of course, all of these organizations that were published around that suffered from a reputational loss. And from an exploit perspective, right, or resource development perspective, if we look at it from the MITRE lens, there was no research of a vulnerability. All they did was identify a configuration gap, meaning Snowflake doesn't enforce MFA really well, build the tool to do the querying, it's just a simple tool, and stage the storage to steal the data, because there's a lot of data. You have to store it somewhere. So they staged a cloud that they could store all the data to. So we got called somewhere in the first day of this campaign by one of our customers. They had some suspicious activity. They thought they had some suspicious activity on Snowflake. They heard some rumors about something that's going on. Nobody was talking about it, so a lot of the big names were already being investigated together with Snowflake and Mandiant, but they kept it hush. And so we were approached with a customer asking us to help, right? And there's no information. You go to Google, search, nobody talks about it yet. So we started reaching out to the professional community. We know a lot of other IR companies, obviously, and our threat intel partners, and we started getting some image of what's going on, right? What's going on was what I showed you, this campaign. And so started getting those bits of disconnected information, and we're starting to get calls from all our customers that have Snowflake, because the rumors are starting to build up in the industry. And everybody with Snowflake is concerned. Am I impacted? Nobody knows. For 3 days, people said Snowflake itself was breached, which was, of course, not true. And so what we did was start looking at how to help our customers with investigating their Snowflake logs. And so part of the challenges in the cloud is that every cloud service has different types of logs, different philosophy for logs. And the SOC teams are just incapable of dealing with all of that, right? So we started figuring out what's going on. We already had some knowledge because that's what we do. And we discovered very quickly, well, first of all, it's doable. You can detect and hunt in Snowflake, but you need to have some understanding with it, and you need to have some understanding with databases. Why? Because Snowflake logs are a database. They're not JSON like any other company logs in the world. They're a database. Also Databricks, by the way, because they're similar. And so they have 4 tables: query history, login history. You can guess from the names what they mean, sessions and access history. And if you look at all of these, you can actually get a really good sense of what a user is doing in Snowflake. And so when we come to look at, are you now being compromised? I can't tell you, again, from a signature that you're compromised, but I can start looking at weird or anomalous behavior. Because a tool that goes and scans all your tables and downloads one by one is not normal behavior, right? And so basically that's what we started to look for, right? And so login history will give you things like IP addresses. So is this a new IP address for a user? Is this user logging in with MFA or not? Do we see brute force? Not that there was brute force in this specific case, right? But also threat intelligence. So as the days evolved through this campaign, we started getting some threat intel from our threat intel partners about some of the IPs that the threat actors were using. So we could start looking for those. But then you can really get a lot of information from the query history. So what do the attackers do? Scanning a lot of data, writing data to new tables, accessing tables that this user has never previously accessed, and so on and so on. So with a pretty quick work, we were able to build a bunch of anomaly detections, and most of our customers, thankfully, were good. One was partially impacted, so it turns out the tool was in some phases, but we were able to see that any type of rare activity and provide some insight, right? And these are things that you don't have to wait for an incident to happen. Those are detections that you can build on your own or run regularly to see if somebody is doing something bad. By the way, almost a year has passed. Snowflake now enforces MFA. You can no longer have Snowflake without MFA. So something good came.
Have they made it easier to use?
No. But they make you use it. Snowflake, either you do single sign-on, and then it's whatever you have, which is good, or if you work with them, it has to be Duo. So I wouldn't say it's the easiest to use, but at least they make you use MFA. So anyway, okay. So let's talk about GitHub. This is really new. This is fun. How many people here have heard about the TJ Actions campaign? Okay, not a lot. So this is from last month. This came out from CISA, Supply Chain Compromise of Third-Party TJ Actions. So TJ Actions is an open source library that you can find on GitHub. And we are seeing an enormous uptick in GitHub attacks for various reasons. But the reason I picked this one, I really like this one for this talk, is because it was done by a compromised identity. So it started, initial access vector was a compromised identity, and the purpose was to get more compromised identities, right? So it's all around compromised identities. So what is TJ Action? So it's a library that helps you track changed files, right? It's not very interesting. Tons of people use it. And an attacker found a way into this library knowing that a lot of people use it. So the adversary compromised a personal access token of the TJ Actions bot. That's an account, a non-human account, that was managing some of the work of the TJ Actions. And they managed to find, we don't know how they got it, but that bot had permissions to write to the repo, okay? Then they created a malicious commit, so they created a new file outside of the repo that is a Python, I'll show you that in a minute, that steals credentials. And they created a pointer to that to be run whenever you run TJ Actions, right? And so I apologize in advance, it's a little technical, but you don't have to read the code. You can just look at the blue part if you don't want to. But basically, the Python here looks for something called runner worker. That's the process of the GitHub that runs your workload and has credentials in it. And it finds in it, in the memory, the secrets that it uses, and it dumps it to the log file. And then the top one, that's what's embedded into the original TJ Actions. You can see that it points to memdump.python. So basically, it looks for a process's runner workers. It searches their memory for secrets, right? The secrets in the memory are not encrypted. So even if you store them encrypted, they're fine in the memory. And then it dumps the secrets into the build logs. And what later they did was just see which projects that used them had the build logs public. So a lot of open source projects, of course, but also non-open source projects where people don't keep the build logs secure. And then they just harvested the credentials from there.
So they're outputting into a public space.
Yes. Well, they just harvest. They don't care if somebody else gets those credentials as well, right? 2 days later, a similar campaign emerged in another library. I'm not going to run very similar. If you want to read it, there's a Wiz blog about it. Very similar. But again, compromised identity, getting more compromised identities. But we're not just looking at this. We are seeing a new age of phishing in GitHub. So this is not phishing where you ask people to give you your credentials. It's phishing where you ask them to give you OAuth authorization. So somebody registered a GitHub account that's called GitHub Security Alerts, right? And they're sending a notification, and it looks like it comes from GitHub. It's a notification of a GitHub security alert. Oh, and you have to deal with it. And to deal with it, you have to authorize the security account, right? And you give them permissions into your repo. 12,000 GitHub repos were targeted with this attack. We don't know how many fell for it, but a lot of them. And we don't know how many of those fell for it and didn't fix it and now have somebody writing new things to what they're doing, right? So how do you deal with it, right? What do you do? How do you handle when your GitHub is being compromised? And again, there's a lot of things you can do, but they are all around looking at the activity, a lot of looking at anomalies or odd behaviors, because there isn't a single signature or pattern that you can say, oh, they use this vulnerability, right? So you can look at things like, do you have a public repo? Is somebody trying to make your repo public? You can look at non-human identities as a baseline for looking at activities that are being abused through non-human identities. And then you can start searching for both anomalous behaviors and just, bad behaviors, right? If somebody's trying to give a non-human identity permissions, you might wonder why that is. And I gave here a few examples. If you want to look more, we have a blog that we released around that time on our website. Just search for it, GitHub Mitiga. And you'll see we have all the detection logic you can take from there if you want to put it in your environment. So you can search for those things. But of course, like any anomaly detection, you need a good baseline, and it can become noisy if you don't fine-tune it. But this is going to stay big for the foreseeable future. GitHub is doing a lot of work to try and identify those things, but it's very difficult. The last story I want to tell, again, it's all about identity, is the Mongo campaign. So this is an amazing campaign. It's been running for years. We've seen it multiple times at customers. Slight tweaks. We've already seen a few variations of this campaign, but still working. Mongo, it's a database, very popular. You can get it in a SaaS version, so it's Mongo Atlas, but a lot of people just deploy the MongoDB on an EC2 machine or any other machine in their environment. So it starts like this. All the times we saw it starts very similar. You get to work one day, you log in, and your Mongo database is gone. In this case, there were 3 databases that were gone. They just disappeared. And you have a new database instead. The new database is called README to recover your data. And in that is a file that says you must pay so-and-so Bitcoin to so-and-so wallet in 48 hours, or your data will be disclosed and deleted, right? So double ransomware. It's both extortion and destruction. So whenever you see something like that, the first question is, do they really have the data, right? Because if they don't, they can't publish it and they also can't recover it. And 2 is, are they reliable? Which is not the same thing. They may have the data, but they're not reliable, right? And so, that's where you always want to investigate. So the recovery is easy, at least in this case with this customer, because they had backup. So they don't want to pay for recovery. Now, do they want to pay for not disclosing? It's to be determined. So let's look at the incident timeline. So just so you get a sense of how this looks. So at 5:13 p.m., somebody accidentally changed a firewall rule that opened the MongoDB port to the internet. And the MongoDB had a default admin account with default password because they never changed it because it was always behind the firewall. And why do security in layers? Not useful at all. 8 minutes later, we see the first instance of reconnaissance picking this up. So as I said, this is a long time campaign. It runs for many years. There are a lot of people in the internet scanning for open MongoDB ports. A lot. And so we saw multiple IPs from different places identifying this scan. And by 521, it was already on Shodan as a known MongoDB with open IP address, right? Just so you see the pace. And by the way, 8 minutes is not even the shortest I've seen because it's a little bit random how fast until they scan it. Took another 2 hours for the exploit. So a lot of these scanners didn't move to the exploit. So they scanned, they saw that's open, but didn't do anything. Eventually, at 7-11, the threat actor started that. It's a fully automated attack, by the way, right? So even that is fully automated. So the actual threat actor reconnaissance from this IP address started, probed this, saw that it was open, and immediately mobilized the attack. And just so you see the numbers, right? So 7-11, 12 seconds. It connects. 7-11, 13 seconds. The databases are deleted. 7-11, 15 seconds. The ransomware node is created. So the whole thing takes 3 seconds. So again, it's not the first time we see that, so we already know that in most of these, they don't actually steal the data. They say they steal the data, but they don't. And you can see it's only 3 seconds, so the chances of them stealing data is low, but we still have to make sure. So what do? So we want to investigate. But the problem, and that was true to every single instance we've seen this attack, is that the same people that didn't change the password of the admin account also didn't turn on the logs on Mongo. So the default logging on Mongo doesn't see any querying. So if they did a query, we can't see it in the logs, right? VPC flow logs are also not enabled, so you can't see any connections. We see the connections on the Mongo log, just that the people connected, but not what was happening to them, size, anything like this. So we have no logs. So at this point, theoretically, the customer is at a point where, most likely didn't steal the data, can't be sure, what do? But we still want to help. So this has worked for us in, I think, 3 out of the 4 instances that we've seen this. Just traffic amounts. So if you go here, you can see this is the traffic amounts to this server. There's almost no traffic, which makes it doable. And during this time of the breach, there is a little bit of traffic. How much is a little bit? 20 kilobytes per second for 3 seconds that this happened. So that's 60 kilobytes roughly. Their 3 databases were 600 megabytes. So clearly, not enough traffic to siphon the whole database, right? And so we can be sure at this point that they didn't steal all the data. We can't be sure that they didn't steal a few records, but ended up deciding not to pay. Again, we've seen this campaign before. It's it's a best effort campaign. You ignore them, they go away. But that's what we see. And again, how can we avoid this? So, well, first thing, make sure your Mongo is hardened. Put passwords the way they should be. Disable anonymous authentication. Do a non-standard admin and limit network access. Turn on logging, which is true for everything you do in the cloud everywhere, so you can assess things. And of course, have some real-time detection and response around these things. So, what now? So how can we detect and stop those breaches, right? And again, what's in common to all of these breaches, that their main pattern for initial access is somebody is logging in with a legitimate account, and if they're not completely bad at this, they're logging in with a legitimate account from a legitimate country in legitimate hours with the right user agent, right? And so we can't immediately tell that something is broken. So, like everything in security, layers, right? We like layers. So prevention. We want to enforce stronger identity controls. The industry is still at a point, MFA is not good enough, and we're still at a point where people don't even have that, right? A lot of organizations still don't have MFA enforced properly. And that's even not good enough at this point. So enforce stronger identity controls, hardware tokens, device-based authentication. Detection. You really want to start applying detection around identity. And the market's now exploding, obviously, with a lot of these ITDR, identity detection. Some of them do a good job, some of them not so much. But there's a reason why it's exploding. We need to start looking at detection. For a decade, we've spent most of our energy detecting malware and endpoints. The big place to look at now is identity. So looking at what you're doing, leveraging AI, I'll talk about it in a minute. But the detection of compromised identities has to be at the behavioral level of what the users are doing, not just at the initial login. And then, of course, be able to respond. Collect the right logs. You can't do anything in the cloud without the right logs. Have the ability to investigate and have the right playbooks to automate response quickly. The good thing about this is that usually, the Mongo is a bad example, but it's also a very automated attack. Usually, compromised identity attacks take time. They log in, they play around, they collect data, reconnaissance, figure out what's interesting, where are the crown jewels. If you discover them at this point, you can stop them before big impact occurred. So, I will stress this in pretty much every talk I do. MFA is not enough. So we say MFA, but we really mean 2FA, right? Username, password, we click this push notification, or we give this little 2-digit number that Microsoft asks us to do, and it's just not enough. Why is it not enough? Because this has been the standard for so long. Attackers have built millions of ways around it, adversary in the middle. Not going to dive too much into it, but again, part of what we do is IR. Every other breach that was a compromised breach, there was MFA in place, right? So MFA, not enough. What do you want to do? You want to leverage a third factor, which is hardware-based. So device-based authentication, hardware, YubiKey, hardware tokens, things like that. Anything around that space is going to make you better. Of course, you don't want to let people logging in from their personal home devices. I know it's a big argument, but it's from a security standpoint, it's outrageous. Using SSO across your entire footprint. I mean, the Snowflake campaign was amazing. These are some of the biggest companies in the world. They have IDP, they have single sign-on, but somehow Snowflake was outside of that, and people could log in without MFA. But the other thing is, and I see this with a lot of customers, so single sign-on initially is not a security feature. It's a usability feature, right? It's easier to log in with single sign-on, and then you enable it so everybody's happy, but you forget to turn off the regular sign-on. So when you connect any SaaS to single sign-on, most of them by default will still allow you to log in with your old username and password. You have no clue about it. You don't see it. It's not in your logs of your main identity provider. So enforce single sign-on as the sole mean of logging in. And then, of course, it's good to have one of those services that monitors threat intel and dark web for stolen credentials. So I want to go back a little bit to data from the IBM report. So one of the things that we're seeing, and it's quite amazing to see, is that one of the biggest areas that impact the rise in cost of data breach is not the actual breach, but the cost of responding to it. So detection and response is becoming more and more expensive, and the cost of data breach is highly dependent on the skill level of your teams. Organizations that have better teams around this would have substantially lower impact. You can see it's almost 50% higher, whereas there's a big skill gap around IR, right? So you can reduce the impact by having the right IR. And we also see, as a result, that most organizations after a breach will increase their security spending. That's normal, right? Because suddenly there's government management support and all that. But most of where people will increase that is in IR planning and testing, is in detection and response. Why? As an industry, for a very, very long time, we've spent way too much on prevention versus detection and response. It's starting to change. I did a talk last year just on this topic, but if you look at the numbers, it's just amazing. And again, I'm not saying prevention is not important. Of course, we still need to put a lot into prevention, but we need to balance those out. And so we can see that the next thing that's going to help us is AI. And I'm really sorry I'm bringing up AI because I know it's been overused, and I'm trying to avoid it as much as I can. But really, specifically in the world of SecOps, of threat detection, AI is amazing. AI can really help shorten time. And this is one of the most amazing figures that came out of this year's report in IBM, is how much AI has been impactful. So organizations that don't use AI will have 50% more impact. They will take 50% more time to detect and respond versus organizations that use AI in their SecOps. So if you still haven't started using AI, that's the time to think about it. And activity logging is your friend. Now, this is a big issue that is still in the early days, but as I said, it's almost impossible, not impossible, of course depends on the specific threat actor, but it's also almost impossible to get good, accurate, consistent detection of compromised identity at your IDP or identity provider level. Why? Because unless they're really bad hackers, they will do the initial login in a good way, right? The right country, the right whatever. And so really the way to detect these is what they do the minute after the login. So they go to Salesforce. They do a bunch of stuff there that you don't normally see that user do. Okay, so it's an anomaly. But to do all that, I need to be able to see beyond security logging. I need activity logging. What's activity logging? If it's in the cloud, it's things like data access, object level, VPC flow. If it's, it's Salesforce, it's all the queries, all the operations. Every cloud provider, every SaaS provider will provide you different tiers of logs. The basic one is, the basic, CloudTrail, security logs, main events. It's not enough to detect those things. You really want the deeper logs. And yes, they're big and they're complicated and they're hard to deal with, but you need to figure out how to do that. So turning on activity logging allows you to do good detection of compromised identities. So we're at the end of the talk. How do we take all this into something actionable? So next week, start with understanding where you are. What's your identity exposure? Do you have a good identity provider to begin with? Do you use single sign-on everywhere? Do you enforce MFA in your IDP? Really enforce on all the accounts, everywhere. Not, here are the 500 excluded ones because they're contractors or whatever, right? And check that all your SaaS applications, everywhere that you connect SSO to, enforces SSO. It's super, super critical. This is one of the quickest wins. Just go, Slack, Salesforce, Snowflake. Make sure that you have this little checkbox that says allow login with legacy accounts or whatever they call that setting. Turn it off. Okay? And assess your personal devices access policy. Do you allow people to use personal devices? Maybe you allow them only if they manage. That's what we do. If somebody wants to bring their own phone or iPad, it's fine, but you have to get our management on that. And start looking at turning on activity logging. Next month, start getting identity maturity and start looking at what your SOC can do for identity detection. So verify the SSO and MFA enforcement. If next week you mapped it out and saw the gaps, by next month, you want to start making sure that you fix all of that. Start looking at hardware tokens or device-based authentication. If you're in Entra, Entra ID, conditional access will let you limit logging only to managed devices. That's what we do. It reduces 90% of this attack vector in a simple setting. Yes, it creates some friction. I won't say it won't. I just saw a startup in the Innovation Sandbox that is trying to make it less, more frictionless, right? So we'll see. But I'm a huge believer in that. Ever since we turned this on, I think 3 years ago in Mitiga, every attempt we had around compromised identity was stopped by that. And start looking at what your SOC can do. A lot of SOCs are still very focused on endpoints. Getting them up to identity is not trivial, and you want to help them get that. And start looking at AI. And then, take this to the next level. Make sure you have hardware-based authentication. And again, for me, Mitiga, we're less than 100 people. I deal with the friction of the device-based authentication. If you have 50,000 employees, you're probably not going to be able to deal with that friction. But you can apply it for specific people, specific resources, high-value target, people with high permissions. And so that can still reduce the attack vector dramatically without creating friction across the entire organization. And start implementing compromised identity detection capabilities. You really want that. You really, really want that, because your next breach, 70% is likely to come from a compromised identity, not from a compromised endpoint. 30% from a compromised endpoint, 70% from a compromised identity. And you want to train your SOC to be able to detect this, to investigate it, to respond to it, to block identities quickly. And just reiterate on that until you're great at that. So that's all I have for today. Happy to take any questions. Thank you. If you want to follow me on LinkedIn, you can. I share content around these things. And I'm happy if anybody has questions, just you'll need to come up to the mic. Sorry? This one? Okay. And the slides are on the RSA website, by the way. So. Yeah, so the question was about repeating about Entra ID. So Entra ID has, if you have the right tier, I think it's P1 or P2, I don't remember, has something called conditional access. In conditional access, you can define the rules in which, when a condition is met, a user may log in. You can set that a rule that the login has to be from an authorized device, a managed and compliant device. It requires you to have an Intune company portal on that device that manages it, and it basically adds a header to every browser request that authenticates this device. I will say it can create friction, especially on mobile, because if an app has an embedded browser rather than using the Safari on your iPhone, then that header doesn't work. So there are small frictions, but it's manageable. Value for money in terms of effort, you turn this on, 90% of this attack vector is gone. Can you speak to the mic?
So you talk about SSO and enabling SSO wherever. Aren't there concerns about breach of identity with SSO providing access to all of those applications?
Of course there is. This is all my talk is about that, essentially, right? And it's true, but the reality is that the alternative where people have passwords to 500 systems is also bad. And when you do that, you have zero enforcement of MFA and logging and so all that stuff. So it's better to use SSA and use 3-factor authentication than to try and manage 500 logins.
Yeah, it also dawns on me too, if you're enforcing SSO, you actually have that visibility. Like
Exactly.
This user logged into this application.
Yeah,
you might
and,
not
and
have
what
that
and by the way, one of the cheap anomaly detections is if you suddenly see a user logging into 20 SSOs when they normally don't do that, that's usually a threat actor going through my apps looking for what they can do. It's the same with Okta. Any other questions? No? Okay, thank you very much.